Hello everyone, hope you all are doing good. I am Anjana from LearnoHub, the free learning platform where you can study math, science and SST absolutely free at learnohub.com. In today's class, we are going to discuss ICSE Class 9 Maths Chapter 1, Rational and Irrational Numbers. We have already discussed what rational number is and what irrational numbers is in our previous videos. If you haven't watched it, go watch them first. Today we'll be discussing about surds and rationalization with examples and solve questions from exercise 1C and exercise 1D. Ready for the session? Let's begin. To understand rationalization, first we need to understand what are surds. For example, if you take this form, that is nth root of x. Here, x should be a positive rational number and this n should be a positive integer. Okay, so this form is a surd and this is an irrational number. Then we call it as a surd. For example, if you can write fifth root of 18. Here 5 is a positive integer, 18 is a positive rational number and this is an irrational number. So it is an example of surd. If you take fourth root of 15, 4 is a positive integer, 15 is a positive rational number. If you take cube root of 12, here 12 is a positive rational number and 3 is a positive integer. So these are examples of surds. So we can define surds as if x is a positive rational number and n is a positive integer such that 1 by x raised to n. 1 by x raised to n is nothing but nth root of x is irrational. Then 1 by x raised to n is called a surd or radical. So this is called a surd. Okay, now I'll give another example. Root of 4. Is this an example of surd? Root of 4 can be written as square root of 2 square. From this we can remove 2, that is a square, and the root. It becomes equal to 2. Here 4 is a positive rational number and n. Here the n value is 2. Square root means n value is 2. It is a positive integer. But what is the difference? The whole thing is not an irrational number. So it cannot be called a surd. If you take cube root of 27. What is the cube root of 27? Cube root 27 can be written as cube root of 3 cube. 27 is 3 into 3 into 3. That is 3 cube. Cube root and cube can be removed and it becomes equal to 3. So here again we are getting a rational number. We need to get an irrational. The answer should be an irrational number. Only then it can be called a surd. So this is also not a surd. Okay. Next, if you take the cube root of 8. What is the cube root of 8? Cube root of 8 is equal to 2. Again a rational number. So this is not a surd. Other two conditions are followed. That is, here the radicand is a positive rational number and the index or the order is a positive integer. 3 is a positive integer. But the answer is not a rational number. So the answer is not an irrational number. Okay. Therefore, this is not a surd. Clear? This is a basic idea of surd. An irrational root of positive rational number. Irrational root of positive rational number is called a surd. Every surd is an irrational number, but every irrational number is not a surd. If you take root 2. Root 2 is a surd. It is an irrational number. We have said that all the surds are irrational number. But when you take pi, pi is an irrational number. We know pi is an irrational number. But pi is not a surd. Okay, so this is a main difference. If you take 3 root 5, 3 root 5 is not a surd, but it is an irrational number. Clear? Now, if you have 4th root of 5, here 5 is a surd of order. We can say that 5 is a surd of order 4. Okay, this is irrational. Here we have a positive rational number and this is a positive integer. So it is 5 is a surd of order 4. If you take cube root of 15. Cube root of 15 is, you can write it as 15 is a surd of order 3. Okay, order 3. The number which comes here is the order, or you call it as index. And this is a radical, or you can call the radical. Okay, next, if you take fifth root of 30, fifth root of 30, you can see this as 30 is a surd of order 5. Okay, so this is how it is. How you can say what the order is. Let us take an example. State with reason which of the following is a surd and which is not. You have two questions. First one, root 27. Root 27 can be written as root 27 is equal to root of 27 is 3 into 3 into 3. Okay, which can be written as 3 root 3. We know root 3 is an irrational number. Okay, then what is 3 into root 3? Product of a rational and an irrational number is also irrational. Therefore, 3 root 3 is irrational. Okay. What about 27? 27 is a rational number. And we have root 27, which is 3 root 3, is an irrational number. Okay, irrational number. Therefore, we will be having the given root 27 is a surd. Okay, this is a surd. So, next example, root of 225 into root of 4. Root 225. This can be written as root of 15 into 15. 15 into 15 is 225 into root of 4. 4 is 2 into 2. Okay. Root of 15 into 15 or root of 15 square is 15 into root of 2 into 2, root of 2 square, which is 2. 15 into 2, we get 30. 30 rational or irrational? 30 is rational. Okay. 30 is a rational number. So, the question also we have this root of 225 into root 4. That is 225 into 4 if you take, it is a rational number. We got 30 is a rational number. Therefore, this is not a surd. So, when you take the root, this one, if you are getting an irrational number, then you will be getting a surd. So, here you are getting a rational number. So, this is not a surd. Rationalization. Rationalization in simple words is a process where an irrational number is made into a rational number. For example, if you take 3 root 2. 3 root 2 we know is an irrational number. Okay, multiplying with some factor will give you a rational number. Okay, should give you a rational number. So, this factor with which the given irrational number is multiplied to get a rational number, we call it as a rationalizing factor. This is a rationalizing factor and this process is called rationalization. For example, 3 root 2. If I multiply with root 2, what happens? 3 root 2 into root 2. This 3 root 2 into root 2 is equal to 3 into root 2 into root 2 is equal to 2. Root 2 whole square, which is 2, and that is equal to 6. 6 we know is a rational number. 6 is a rational number. Okay, so here the process of rationalization is done and the rationalizing factor in this case is equal to root 2. Now I am asking, is it only root 2 that is multiplied to the irrational number 3 root 2 will give you a rational number? Is there any other numbers that can be multiplied? For example, I am taking the same 3 root 2 and multiplying with some other different number and I am getting a rational number. And this number will also be the rationalizing factor. Yes, for example, I am multiplying with 2 root 2. Then what do we get? We will be getting 3 into 2 into root 2 into root 2, which is equal to 3 into 2 into root 2 into root 2 is equal to 2. Okay, 3 2s are 6, 6 2s are 12. Okay, again 12 is a rational number. 12 is a rational number. And we can say that 2 root 2 is a rationalizing factor. I am taking the same 3 root 2 and multiplying with some other different number and I am getting a rational number. Okay. Let's say I am multiplying with 3 root 2. Then I will be getting 3 into root 2 into root 2, which is equal to 3 into 2, and that is 3 3s are 9. 9 into 2, which is equal to 18. Okay, which is equal to 18. 18 is a rational number. Okay, so 3 root 2 is also a rationalizing factor of 3 root 2. Okay, so here we will be getting infinitely many rationalizing factor for a given irrational number. And this thing, that is root 2, the first one we have taken is the lowest rationalizing factor, or you can say least rationalizing factor. In this case, least rationalizing factor is equal to root 2. The lowest number, lowest irrational number that can be multiplied to the given irrational number to get a rational number is called the lowest rationalizing factor or least rationalizing factor. Clear? Let us take a surd. Root 3 minus root 2 is a surd. Okay, when this root 3 minus root 2 is multiplied with another surd, you should get a rational number. Okay, for example, here you have root 3 minus root 2. I am multiplying with the conjugate of this number. Conjugate of this number means a positive sign. This root 3 plus root 2. What do we get? A plus b into a minus b, root 3 square minus root 2 square, which is equal to 3 minus 2, that is 1, which is a rational number. So we can say that for this surd, root 3 minus root 2, the rationalizing factor is root 3 plus root 2. That is a conjugate surd. Okay. Similarly, vice versa. That is for root 3 plus root 2, the rationalizing factor is root 3 minus root 2. If you have another number, 1 by root 5 minus 2 root 2. Okay, what is the rationalizing factor of this? Take the denominator and change the sign. Here it is negative sign. You have to make the positive sign. Then you will be getting the rationalizing factor. So here the rationalizing factor is equal to root 5 plus 2 root 2. Okay, that is 1 by root 5 minus 2 root 2 into numerator and denominator. You are going to multiply with this number, with this conjugate. That is root 5 plus 2 root 2 divided by root 5 plus 2 root 2. In the numerator, you will be getting root 5 plus 2 root 2. Denominator, a plus b into a minus b form. That is root 5 square minus 2 root 2 whole square, which is equal to root 5 plus 2 root 2 divided by root 5 square is 5 minus 2 root 2 square. 2 square 4, 4 into 2, 8, which is equal to minus root 5 plus 2 root 2 divided by 5 minus 8 is equal to minus 3. I have taken this negative to the numerator. Denominator, you will be having 3. So you can check that here we had an irrational number in the denominator and here the denominator has become a rational number. So this process is called rationalization, and in the process of rationalization you will be having a rationalizing factor. For example, if the form is a plus root b. Okay, the rationalizing factor will be a minus root b. Root a plus root b. Then the rationalizing factor is root a minus root b. If you have root c minus root d, then the rationalizing factor will be equal to root c plus root d. Okay, so this is how you can find the rationalizing factors. Clear? Second example, find the least rationalizing factor of first one, root 27. To find the least rationalizing factor of root 27 can be written as root of 3 into 3 into 3. Okay, 2 of these 3's can be taken out. It becomes 3 root 3. So to find the least rationalizing factor, multiplying with something will give you a rational number. For that, when you take this root 3 and multiply with 3 root 3, 3 root 3 into this number, that is root 3, into this irrational number root 3, you will be getting 3 into 3, which is equal to 9. 9 is a rational number. Okay, 9 is a rational number. So here this root 3, here the root 3 which we have taken, this root 3 is the least rationalizing factor. Least rationalizing factor. So next one, 2 root 125. Okay, root 125. Root 125 can be written as root of 5 into 5 is 25. 25 into 5 is 125. Okay, from here we can take 5 out. From these two 5s considered, we can take a 5 out. Inside the root you will be having a 5. So here we have 2 root of 125, which is equal to 2 into 5 root 5, that is 10 root 5. Okay, 10 root 5. Now to get the least rationalizing factor, here we have a root 5. 10 root 5 into root 5 will be equal to 10 into root 5 into root 5 is 5, which is 50. We are getting a rational number. So to get a rational number, we are multiplying 10 root 5 with root 5. That is the root 5 which you obtain from here. So this root 5 is a least rationalizing factor. Here, least rationalizing factor is root 5. Okay, understood how to find the least rationalizing factor? Example 3, simplify each of the following by rationalizing the denominator. How to rationalize the denominator? Let's take the first example. 1 divided by 3 minus root 7. So you have to change this sign. Okay, here we have minus sign. So while multiplying numerator and denominator, we have to take positive sign. That is 3 plus root 7 divided by 3 plus root 7. So here the rationalizing factor is 3 plus root 7. We are multiplying the numerator and denominator with 3 plus root 7. Okay, so the numerator 1 into 3 plus root 7 is 3 plus root 7 divided by 3 minus root 7 into 3 plus root 7. What do we get? A plus B into A minus B is A square minus B square. Therefore, 3 square minus root 7 whole square, which is equal to 3 plus root 7 divided by 3 square 9 minus root 7 whole square. Root and square can be removed, then we get 7, which is equal to 3 plus root 7 divided by 9 minus 7 is 2. So this is your answer. Okay. So we have rationalized the denominator. Now the second example. Root 3 minus root 2 divided by root 3 plus root 2. So to get the rationalizing factor, how to get the rationalizing factor? Take the denominator, change the sign. Here it is positive, the sign becomes negative. So root 3 minus root 2 divided by root 3 minus root 2. Numerator and denominator we are multiplying with this rationalizing factor. Okay, numerator what do we get? Here we have root 3 minus root 2, again root 3 minus root 2, therefore the product will be root 3 minus root 2 whole square divided by A plus B into A minus B. Root 3 plus root 2 into root 3 minus root 2, A square minus B square. Root 3 square minus root 2 square, which is equal to A minus B whole square. A square minus 2AB plus B square. Here A square will be root 3 square minus 2. A is root 3, B is root 2 plus B square, which is root 2 whole square, divided by A square minus B square. Root 3 whole square is 3 minus root 2 whole square is 2. Okay, that is equal to root 3 square, we get 3 minus 2 into root 3 into root 2. That is 2 into root of 3 into 2, which is 2 root 6 plus root 2 square is 2 divided by 1. Okay, 3 minus 2 is 1. So finally you will be getting 3 plus 2, which is 5 minus 2 root 6. Okay, 5 minus 2 root 6. Now the third one, 7 divided by root 15 plus 2 root 2. So here what is the rationalizing factor? Yes, you have to change this positive to negative. Then you will be getting root 15 minus 2 root 2 divided by again root 15 minus 2 root 2, which is equal to 7 into root 15 minus 2 root 2. You can write as it is root 15 minus 2 root 2 whole divided by A plus B into A minus B. Therefore, root 15 whole square minus 2 root 2 whole square, which is equal to 7 into root 15 minus 2 root 2 divided by root 15 whole square. Root and square can be removed, then you will be getting 15 minus 2 root 2 square. How to get 2 root 2 square? 2 root 2 into 2 root 2. 2 2s are 4 into root 2 into root 2 is 2, which is equal to 8. Okay, so here you will be getting 8. That is 7 into root 15 minus 2 root 2 divided by 15 minus 8, which is again 7. So this 7 and this 7 can be cancelled, and your final answer is root 15 minus 2 root 2. So this is where we have done rationalizing. Clear? Example 4, find the value of A and B if 2 root 3 plus 3 root 2 divided by 2 root 3 minus 3 root 2 is equal to A plus B root 6. So here we have to take the left hand side first. The left hand side we have 2 root 3 plus 3 root 2 divided by 2 root 3 minus 3 root 2. First step, take the denominator, find the rationalizing factor. Here we have negative sign, change it to positive sign and multiply the numerator and denominator. So you will be getting 2 root 3 plus 3 root 2 divided by 2 root 3 plus 3 root 2, which is equal to A plus B into A plus B, which is A plus B whole square. Therefore, 2 root 3 plus 3 root 2 whole square divided by A minus B into A plus B is A square minus B square. That is 2 root 3 whole square minus 3 root 2 whole square. Okay. So, here first A plus B whole square. A square is 2 root 3 whole square plus 2AB. 2 into 2 root 3 into 3 root 2 plus B square, 3 root 2 whole square. Divided by, dividing throughout by A square minus B square, that is 2 root 3 square minus 3 root 2 square. Okay. 2 root 3 square, how much do we get? 2 root 3 into 2 root 3. 2 root 3 into 2 root 3, which is 2 into 2, 4 into root 3 into root 3 is 3, equal to 12. 4 into 3, 12. Next, 2 into 2 into 3. 2 2s are 4, 4 3s are 12. Plus 12, root 3 into root 2, which is root 6. Next, 3 root 2 square. 3 root 2 into 3 root 2. Which is equal to 3 3s are 9 into root 2 is 2, we get 18. So, plus 18 divided by 2 root 3 square is 12 minus 3 root 2 square, which is equal to 18. 12 plus 18, how much do we get? 12 plus 18 is 30 plus 12 root 6 divided by 12 minus 18, which is minus 6. So, when there is negative sign in the denominator, you can take it to the numerator. This becomes minus 30 plus 12 root 6 divided by 6. Okay, or that is minus 30 by 6 minus 12 root 6 divided by 6. Okay, you are distributing this negative sign and the 6 belongs to both of these. Denominator will be 6. Okay, minus 30 divided by 6 will be equal to minus 5. Minus 12 root 6 divided by 6 will be equal to minus 2 root 6. Okay, now we have to compare it with this right hand side. This part, minus 5 minus 2 root 6 is equal to A plus B root 6. Then what is A? A is this value. A will be equal to minus 5. B is this value, that is with root 6. Okay, B is equal to -2. So we have determined the values of A and B. Now let us solve problems from exercise 1C. So here we have the first problem, question 1 of exercise 1C. State with reason which of the following are surds and which are not. First one, root of 180. You have to first determine whether it is a rational number or irrational number. If it is irrational, then it will be a surd, and if it is rational, it will not be a surd. Okay. So first one is root of 180. Root 180 can be written as root of 2 into 2 into 3 into 3 into 5. 2 2s are 4, 4 3s are 12, 12 into 3 36, 36 into 5 is 180. Okay, so here from these two, 1 2 can be taken out. From these 3's, you can take 1. Then you have root 5. Since root 5 is irrational, this whole thing will be irrational. Okay, therefore this is irrational. When it is irrational, it will be a surd. Okay, now the second one, 4th root of 27, which can be written as 4th root of 3 into 3 into 3. 27 is 3 cube, which is 3 into 3 into 3. This is again irrational, right? This is irrational, and hence it is a surd. Now the third one, 5th root of 128. 5th root of 128. 2 into 2, 4, 4 into 2, 8, 8 into 2, 16, 16 into 2, 32, 32 into 2, 64, into 2 is 128. Okay. Now 1, 2, 3, 4, 5. These 5 together can be taken out because this is 5th root. Remaining what do we have? 5th root of 2 into 2, which is 4. Okay. This is again irrational. Hence, this is also an example of surd. Next, 4th one, cube root of 64. How can you write the cube root of 64? This is equal to cube root of 4 into 4 into 4. 4 4s are 16. 16 into 4 is 64, which is equal to cube root. When taken, you will be getting 4. We have 3 times 4 here. Okay. What is 4? 4 is a normal number, that is a rational number. Since this is a rational number, the given number, that is cube root of 64, is not a surd. Okay, because here we are getting a rational number. So next one, cube root of 25, cube root of 40. Okay, first cube root of 25. Cube root of 25 is 5 into 5. Cube root of 40. How can you write 40? 2 into 2 into 2 into 5. 2 2s are 4, 4 2s are 8, 8 5s are 40. Okay. So here this cube root can be taken as whole. Then you have 5 into 5 from here. And here we have 2 into 2 into 2 into 5. Okay. That is cube root of 5, 5, 5. Okay. 5 cube into 2, 2, 2, which is 2 cube. Okay, so when you are taking it out, you will be getting 5 into 2. Cube root and cube can be removed together. 5 into 2, what is 5 into 2? Which is 10. 10 we know is a rational number. Therefore, this is not a surd. Not a surd. So, next one. Here we need the cube root of minus 125. How do we get minus 125? Cube root of minus 5 into minus 5 is 25. 25 into minus 5 is minus 125. So when you take the cube root, what is the cube root? Cube root will be minus 5. Okay, minus 5 we know is a rational number. This is a rational number and hence not a surd. Next is root pi. Pi we already know is irrational. Okay. Pi is irrational. Therefore, root pi will also be irrational. And hence this is a surd. Next is 3 plus root 2 whole root. So here this part when taken, we know this is irrational. Root 2 is irrational. Therefore, rational number plus an irrational number will also be a irrational number. Therefore, when you take root of that irrational number, what do we get? You will be getting it to be irrational. So, when it is irrational, it should be a surd. Okay. So, here we have 8, questions. The first one is a surd, second is a surd, third is a surd, then fifth one is a surd. So here we have 8 questions in this first, second, third, 7th and 8th one are the surds. Second problem, question 2 of exercise 1C. Write the lowest rationalizing factor of first one root 24 and second root 18 minus root 50. So first one let's take to find the lowest rationalizing factor. Lowest rationalizing factor and the least rationalizing factor are the same. So root 24. This can be written as root of 2 into 3 into 2. 2 2s are 4, 4 3s are 12. 12 2s are 24. Okay. So from here you can take from these two 2's you can take a 2 outside. Remaining you will be having 3 into 2 which is 6. 6 is an irrational number. Root 6 is an irrational number. Therefore you will be having the least or the lowest rationalizing factor is equal to root 6. So when this number, that is 2 root 6, is multiplied with root 6, you will be getting 12, which is a rational number. So to get a rational number, the least rationalizing factor should be multiplied with it. So here it is root 6. Now the second one, root 18 minus root 50. How can you write root 18? Root 18 can be written as root of 2 into 3 into 3. What about root 50? Root 50 is equal to root of 2 into 5 into 5. Okay. So now root 18 minus root 50 will be equal to root of 2 into 3 into 3 minus root of 2 into 5 into 5, which is equal to. So here we have 2 3's. One can be taken out. 3 root 2 minus. Here we have 2 5's. One can be taken off. 5 root 2. 3 root 2 minus 5 root 2. What do we get? Just minus 2 root 2. Okay. Minus 2 root 2. So here when you get minus 2 root 2, to get a rational number, you have to multiply with this root 2. Okay. Therefore, lowest rationalizing factor is equal to root 2. So when you multiply 2 root 2 minus 2 root 2 with root 2, you will be getting minus 4, which is a rational number. To get a rational number, you are multiplying with the lowest rationalizing factor, which here is root 2. Problem number 3. Question 3, sub-question 5 of exercise 1C. Rationalize the denominators of 2 minus root 3 divided by 2 plus root 3. So here 2 minus root 3 divided by 2 plus root 3. What is the rationalizing factor in this case? Rationalizing factor here it is. Here in the denominator we have 2 plus root 3. Therefore the rationalizing factor is, you have to change the sign. It becomes 2 minus root 3. So you are going to multiply the numerator and denominator with 2 minus root 3. 2 minus root 3 divided by 2 plus root 3 into 2 minus root 3 divided by 2 minus root 3, which is equal to 2 minus root 3 into 2 minus root 3, a minus b whole square form, that is 2 minus root 3 whole square divided by, here a plus b into a minus b, which is a square minus b square, 2 square minus root 3 whole square, which is equal to 2 minus root 3 whole square, a square, 2 square minus 2ab, 2 into root 3 plus b square, which is root 3 whole square, divided by, here we have 2 square minus root 3 square. Okay. That is equal to 2 square is 4 minus 2 into 2 4, 4 into root 3 is minus 4 root 3 plus root 3 whole square, which is 3, divided by denominator 2 square 4 minus root 3 square 3. Okay, 4 plus 3 7 minus 4 root 3 divided by 1. The answer, final answer is 7 minus 4 root 3. 7 minus 4 root 3. Problem number 4, question 3, sub-question 9 of exercise 1C. Rationalize the denominator of 2 root 5 plus 3 root 2 divided by 2 root 5 minus 3 root 2. Okay. To rationalize the denominator, first we have to take the denominator and find the rationalizing factor. Here the denominator is 2 root 5 minus 3 root 2. Therefore, the rationalizing factor will be equal to 2 root 5 plus 3 root 2. Just changing the sign. This negative sign becomes positive sign. Okay. Now, we have to multiply the numerator and denominator of the given fraction with this rationalizing factor. So, here we have 2 root 5 plus 3 root 2 divided by 2 root 5 minus 3 root 2 into 2 root 5 plus 3 root 2 divided by 2 root 5 plus 3 root 2, which is equal to, here a plus b into a plus b whole square. Therefore, 2 root 5 plus 3 root 2 whole square divided by a plus b into a minus b, which is 2 root 5 whole square, a square minus b square, 3 root 2 whole square. Okay, which is equal to 2 root 5 whole square plus 2ab, 2 into 2 root 5 into 3 root 2 plus b square, 3 root 2 whole square divided by a square minus b square form, which is 2 root 5 whole square minus 3 root 2 whole square, which is equal to 2 root 5 square. How to find 2 root 5 square? 2 root 5 into 2 root 5, 2 into 2 4 into root 5 into root 5 is 5, which is equal to 20. We get 20 here plus 2 into 2 root 5 into 3 root 2. 2 into 2 4, 4 into 3, which is 12. Root 5 into root 2 is root of 5 into 2, which is equal to root 10 plus 3 root 2 square, 3 root 2 into 3 root 2, 3 into 3 is 9, root 2 into root 2 is 2, which is equal to 18. Okay, so 18 divided by 2 root 5 whole square we have determined, which is 20, minus 3 root 2 square is 18, equal to 20 plus 18 is 38 plus 12 root 10 divided by 20 minus 18, which is 2, equal to, here 2 can be taken out, then you will be having 19 plus 6 root 10 divided by 2. We are taking out 2 because you can cancel the denominator. From denominator we have a 2 which can be cancelled. For that purpose we are taking 2 as a common factor. 2 and 2 gets cancelled, then you have 19 plus 6 root 10. Okay. So this is your final answer, 19 plus 6 root 10. Next, problem number 5. Question 4, sub-question 4 of exercise 1C. Find the value of A and B. Take the left hand side first. So here we have solved a similar question before. 5 plus 3 root 2 divided by 5 minus 3 root 2 we have in the left hand side. 5 plus 3 root 2 divided by 5 minus 3 root 2. Take the denominator. Here the denominator is 5 minus 3 root 2. So next what we have to do? We have to find the rationalizing factor. To get the rationalizing factor, we have to change the sign. Therefore, here the rationalizing factor of denominator 5 minus 3 root 2 is 5 plus 3 root 2. Okay. Now, multiplying the numerator and denominator with 5 plus 3 root 2. So, we will be getting 5 plus 3 root 2 divided by 5 minus 3 root 2 into 5 plus 3 root 2 divided by 5 plus 3 root 2, which is equal to a plus b into a plus b whole square, 5 plus 3 root 2 whole square divided by a square minus b square, which is 5 square minus 3 root 2 whole square, equal to a plus b whole square. A square is 5 square plus 2 into 5 into 3 root 2 plus b square, which is 3 root 2 whole square, divided by 5 square is 25 minus 3 root 2 whole square. How to find 3 root 2 whole square? 3 root 2 into 3 root 2. 3 into 3, 9. Root 2 into root 2 is 2, which is equal to 18. Okay. So, here we will be having 18. That is equal to 5 square is 25 plus 2 into 5, 10. 10 into 3, 30. 30 root 2. 30 root 2 plus 3 root 2 whole square. 3 root 2 whole square is 18. Divided by 25 minus 18, which is equal to 7. So, this is 25 plus 18, which is equal to 43 plus 30 root 2 whole divided by 7. This is your final answer. Okay. So, now we have to compare this with the right hand side, a plus b root 2. So, 43 by 7 plus 30 root 2 divided by 7 is equal to a plus b root 2. On comparing, here we have a root 2, here also we have root 2. So, this is the term, okay, containing root 2. Then a will be equal to this part, which is 43 by 7, and b is this part, which is 30 by 7. Okay, a is 43 by 7 and b is 30 by 7. Problem number 6, question 5 of exercise 1C, simplify 22 divided by 2 root 3 plus 1 plus 17 divided by 2 root 3 minus 2. So, we have to consider the denominators of both these terms and take the LCM of them. So, here we have 2 root 3 plus 1 and 2 root 3 minus 1. Then what will be the LCM? LCM will be 2 root 3 plus 1 into 2 root 3 minus 1. So, this can be written as denominator is 2 root 3 plus 1 into 2 root 3 minus 1. Okay. Now, check the terms. So, here we have 2 root 3 plus 1. Okay. 2 root 3 plus 1 into 2 root 3 minus 1. So, this 2 root 3 minus 1 into 22 will be the first part. 22 into 2 root 3 minus 1 plus 17 into, here we already have 2 root 3 minus 1. Therefore, multiply these two. 17 into 2 root 3 plus 1. 2 root 3 plus 1. Okay. So, that is equal to, removing the brackets and multiplying 22 into 2 root 3 minus 22 into 1. Okay. Plus 17 into 2 root 3 plus 17 into 1 whole divided by. Here this is of the form a plus b into a minus b. Therefore, 2 root 3 whole square minus 1 square, which is equal to 22 into 2, 44, 44 root 3 minus 22 into 1 is 22 plus 17 into 2, that is 34, 34 root 3 plus 17 whole divided by 2 root 3 whole square. 2 square 4, root 3 square is 3, 4 into 3, 12. 12 minus 1 square is 1. Okay. 44 root 3, 34 root 3. What do we get on adding? You will be getting 78. 78 root 3. Then you have minus 22 and plus 17, which is minus 22 plus 17 is minus 5. Divided by 12 minus 1, 11. So, this is your final answer. 78 root 3 minus 5 divided by 11. Okay. Problem 7, question 6 of exercise 1C. If x is equal to root 5 minus 2 divided by root 5 plus 2 and y is equal to root 5 plus 2 divided by root 5 minus 2, find first one x square, second y square, third xy and fourth x square plus y square plus xy. So, here finding 1, 2 and 3, you can find the fourth one. Okay. So, let's start. So, first one, to find x square, we have x given, x is equal to root 5 minus 2 divided by root 5 plus 2. Then what is x square? How to find x square? Square both the numerator and denominator. Root 5 minus 2 whole square divided by root 5 plus 2 whole square. that is equal to a minus b whole square is a square minus 2ab plus b square. So a square root 5 square minus 2 root 5 into 2 plus b square 2 square divided by root 5 plus 2 whole square, that is root 5 square plus 2 root 5 into 2 plus 2 square, which is equal to root 5 square is 5 minus 2 2s are 4, 4 into root 5. 4 root 5 plus 4 divided by root 5 square again 5 plus 4 root 5 plus 4, which is equal to 5 plus 4 9 minus 4 root 5 divided by 5 plus 4 again 9 plus 4 root 5. Okay, so we got 9 x square is equal to 9 minus 4 root 5 divided by 9 plus 4 root 5. Next, what should be done? You have to rationalize. So, for that purpose, take the denominator, find the rationalizing factor. Denominator is 9 plus 4 root 5. So, the rationalizing factor will be 9 minus 4 root 5, multiplying numerator and denominator with 9 minus 4 root 5. We get 9 minus 4 root 5 into 9 minus 4 root 5, that is 9 minus 4 root 5 whole square divided by a plus b into a minus b, that is 9 square minus 4 root 5 whole square, which is equal to a minus b whole square, a square, that is 9 square minus 2 into 9 into 4 root 5 plus 4 root 5 whole square divided by 9 square is 81 minus 4 square is 16, root 5 square is 5, 16 into 5 which is 80. That is equal to again 9 square 81 minus 2 into 9 18, 18 into 4 72, 72 root 5 plus here we again get 80 divided by 81 minus 80 is equal to 1. Okay, then we are having 81 plus 80 which is equal to 161 minus 72 root 5. 161 minus 72 root 5. So, we will write x square is equal to 161 minus 72 root 5. Okay, now let's find what y square is. To find y square, we have y is equal to root 5 plus 2 divided by root 5 minus 2. Then how to get y square? Y square will be equal to root 5 plus 2 whole square divided by root 5 minus 2 whole square, which is equal to a plus b whole square, that is a square, root 5 square which is 5 plus 2ab, 2 into 2 4, 4 into root 5 4 root 5 plus b square 2 square 4 divided by root 5 minus 2 whole square, that is 5 root 5 square 5 minus 2 into 2 4, 4 root 5 plus 2 square 4, which is equal to 5 plus 4 9 plus 4 root 5 divided by 9 minus 4 root 5. So here what is the rationalizing factor? 9 plus 4 root 5 we have in the denominator, therefore rationalizing factor will be 9 plus 4 root 5. 9 plus 4 root 5 divided by 9 plus 4 root 5. Okay, 9 plus 4 root 5 whole square. What is 9 plus 4 root 5 whole square? 9 square 81 plus 2 into 9 into 4 root 5. What is 2 into 9 into 4 root 5? Here we have 2 into 9 into 4 root 5 which is 72 root 5 plus 4 root 5 whole square. 4 root 5 whole square is 80 divided by, denominator is the same, 9 minus 4 root 5 into 9 plus 4 root 5. 9 plus 4 root 5 into 9 minus 4 root 5. We are getting 81 minus 80 which is equal to 1. Denominator will be 1. So, adding you will be getting 80 plus 81 which is 161 plus 72 root 5. So, we got y square. Y square is equal to 161 plus 72 root 5. Next, we'll have to find xy. So, third part, to find xy. Here, x is equal to root 5 minus 2 divided by root 5 plus 2, and y is equal to root 5 plus 2 divided by root 5 minus 2. Okay. Numerator, a minus b into a plus b. Therefore, a square, root 5 square minus b square, 2 square divided by. Here again, a plus b into a minus b, root 5 square minus 2 square, which is equal to root 5 square is 5 minus 2 square 4 divided by again 5 minus 4, which is equal to 1. 1 divided by 1, which is 1. Therefore, we are getting xy is equal to 1. So, the fourth part of the question is to find what is x square plus y square plus xy, that is equal to x square. X square is 161 minus 72 root 5 plus y square is 161 plus 72 root 5 and xy is equal to 1. Okay, so this 72 root 5 and minus 72 root 5 can be cancelled. 161 plus 1, that is equal to 300 and so 161 plus 161 plus 1, you will be getting 323. So, this is your final answer. X square plus y square plus xy will be equal to 323. Okay. Now, we will solve questions from exercise 1D. Problem 8, question 4 of exercise 1D. If x is equal to root 3 minus root 2, find the value of first one x plus 1 by x and the second x square plus 1 by x square. Okay, here x is given, x is equal to root 3 minus root 2. Then what is 1 by x? 1 by x will be equal to 1 by root 3 minus root 2. So, you have to rationalize this first. For that, you have to find the rationalizing factor. Here the denominator is root 3 minus root 2, which means changing the sign, it becomes plus sign. We get the rationalizing factor to be equal to root 3 plus root 2 dividing and multiplying. 1 into root 3 plus root 2, that is root 3 plus root 2 divided by root 3 minus root 2 into root 3 plus root 2, that is equal to a square minus b square, which is root 3 square minus root 2 square equal to root 3 plus root 2 divided by root 3 square is 3 minus root 2 square is 2, and that is equal to root 3 plus root 2 divided by 1, which is root 3 plus root 2. So, we got 1 by x. Then what is x plus 1 by x? X plus 1 by x is equal to root 3 minus root 2 plus 1 by x is root 3 plus root 2, which is equal to minus root 2 and plus root 2 can be cancelled. We have root 3 plus root 3, which is 2 root 3. Therefore, x plus 1 by x is equal to 2 root 3. Now, the second part of the question, we have to find what is x square plus 1 by x square. Okay, you can find x square and 1 by x square separately and then do, or else there is an easy way. We know that a plus b whole square is equal to a square plus 2ab plus b square. Then, what is a square plus b square? A square plus b square will be a plus b whole square minus 2ab. That is, I am taking this to the opposite side. Minus 2ab. Okay. So, here we have, in place of a, we have x, and in place of b, this part, that is b square, we have 1 by x square. Okay. So, on considering this, you will be getting x square plus 1 by x square. That is, everywhere in place of a, we are going to put x, and in place of b, we are going to put 1 by x. Okay. X plus 1 by x whole square minus 2 into x into 1 by x. This x and this x can be cancelled and you will be having only 2 then. So, this is equal to x plus 1 by x whole square minus 2. Okay. This is x plus 1 by x whole square minus 2. We know what is x plus 1 by x. So, first part we have determined what is x plus 1 by x, which is equal to 2 root 3. Okay, this becomes 2 root 3 whole square minus 2, which is equal to 2 square 4 into root 3 square is 3 minus 2. 4 into 3, you will be getting 12 minus 2, which is equal to 10. So 10 is your final answer. Next problem 9, question 8 of exercise 1D. Show that 4 minus root 5 divided by 4 plus root 5 plus 2 divided by 5 plus root 3 plus 4 plus root 5 divided by 4 minus root 5 plus 2 divided by 5 minus root 3 is equal to 52 divided by 11. So here separately we will be taking each term and rationalizing. After that we will find the sum and see and check whether this is equal. Okay, we have to show that left hand side and right hand side are equal. So we will start with the left hand side. So take the first term. Here the first term is 4 minus root 5 divided by 4 plus root 5. So here what is the rationalizing factor? Check the denominator. Denominator is 4 plus root 5. So rationalizing factor should be 4 minus root 5. Here also 4 minus root 5. So 4 minus root 5 whole square divided by 4 square minus root 5 square, which is equal to 4 minus root 5 whole square. 4 square 16 minus 2 into 4 8. 8 into root 5 plus root 5 square is 5 divided by 4 square 16 minus root 5 square. Root 5 square is 5. Okay. So 16 plus 5, which is 21. 21 minus 8 root 5 divided by 16 minus 5, which is 11. So we have determined the first part, that's the first term. Now the second term, take the second term, 2 divided by 5 plus root 3. Here the rationalizing factor will be 5 minus root 3. Again 5 minus root 3, which is equal to 2 into 5 minus root 3 divided by 5 plus root 3 into 5 minus root 3, which is 5 square minus root 3 square, equal to 2 into 5 minus root 3 divided by 5 square 25 minus root 3 square, which is 3. So you will be getting 2 into 5 minus root 3 divided by 25 minus 3 is 22. So this 2 and 22 can be cancelled, you get 11. So you will be getting 5 minus root 3 divided by 11. Now the third term is 4 plus root 5 divided by 4 minus root 5. Now the rationalizing factor will be 4 plus root 5, again 4 plus root 5, which is equal to a plus b whole square. 4 square 16 plus 2 into 4 8 into root 5 8 root 5 plus root 5 square, which is 5 divided by a plus b into a minus b. Same here we have 4 plus root 5 into 4 minus root 5, which is equal to 11. Okay, so denominator will be 11. You get 16 plus 5 21 plus 8 root 5 divided by 11. Now the fourth term 2 by 5 minus root 3. Rationalizing factor is 5 plus root 3, 5 plus root 3, which is equal to 2 into 5 plus root 3 divided by denominator 5 minus root 3 into 5 plus root 3. Here we have 5 minus root 3 into 5 plus root 3, which is equal to 22. We are getting 22 again. So this 2 and 22 gets cancelled. You get 11 here. So adding all these. So first one, after rationalization, we have 21 minus 8 root 5 divided by 11. Second term, after rationalization, we have 5 minus root 3 divided by 11. Third term, after rationalization, 21 plus 8 root 5 divided by 11 plus fourth term is 5 plus root 3 divided by 11. Okay, that is equal to. So in the denominator, we have 11. Okay, then 21 minus 8 root 5 plus 5 minus root 3 plus 21 plus 8 root 5 plus 5 plus root 3. So here 21 plus 21, that is equal to 42 minus 8 root 5, and plus 8 root 5 can be cancelled. 5 plus 5 which is 10 minus root 3 plus root 3 can be cancelled. Okay, denominator we have 11. 21 and 21 we have taken, which is 42. 42 plus 10 which is 52 divided by 11. This is the right hand side. Here we have 52 divided by 11. So hence proved. Problem 10. Question 10 of exercise 1D. Show that x is irrational if first one, x square is equal to 6. If x square is equal to 6, then x will be equal to root of 6. We know root 6 is an irrational number. Therefore, x is irrational. Second, x square is equal to 0.009. This can be written as x square is equal to 9 divided by 1000, 3 decimal. Okay, 9 by 1000. Then what is x? X will be the square root of 9 by 1000. That is root 9 divided by root of 1000, which is equal to root 9 is 3 divided by root 1000. That is 1000 is 10 into 10 into 10 will be equal to 3 divided by 10 can be taken out. Then you have root 10. Okay, 3 divided by 10 root 10. What is this? This is an irrational number. Okay, so this is irrational. X is irrational. Here we have inside the root 10. Okay. Next, x square is equal to 27. Then x will be equal to root of 27. What is root of 27? Root of 3 into 3 into 3. Okay, factors of 27. 3 can be taken out. 3 root 3. Root 3 is irrational. Therefore, 3 root 3 will be irrational. Root 27 will be irrational. X is again irrational. Okay, that's all for today. In today's class, we have discussed about what surds are and what is rationalization. We have solved many examples and solved questions from exercise 1C and 1D. Hope you all have enjoyed the session. There are a few more questions left which you can solve on your own. I'll be back with the new chapter in the next session. Until then, stay tuned to LearnoHub. LearnoHub free hai, par best hai. Thank you.